All right, I want to start, please, everybody. Silencio. Please, everyone, be quiet.
I told us that you're wrong.
We're starting. We're talking about pipes. We mentioned it last time. With pipes. Why do we give a pipe an array of two integers? Review questions.
To the first and second.
Yeah, why do we give it why do we give it two integers like this?
Yeah, a reference who's gonna be, one side of the pipe, one not the other.
One is for reading, one is for writing. Which one is for reading? Which one's for writing?
Reading is 0, writing is 1.
Right. Reading is 0, just like the keyboard. Okay, so we saw this example last time where hello father was written to the pipe and the child process received from the pipe. Did we have an example? It's so actually, wait a second. We did this example, this one, right? This one is there's only one process without a fork.
Oh, yeah, we did the trivial example.
Trivial example. We didn't do the other example, I don't think.
We have not.
So let's look at this example. Even if we did it, we'll do it again. This example is where you have a child and a parent. Where the pipe is created, we have a single pipe. And then we do a fork, which means that we now have two processes. If we would do the pipe after the fork, then we would have two pipes, and when a child would write to one pipe, the father would read from another pipe, and they would never talk to each other. You'd want to have only one pipe. So you first create the pipe, and then you do a fork. Now, what happens is this variable FD gets doubled. You have two of them now. But the pipe itself is only one. Because it's like a file. When you do a fork, you don't create another file. You don't have all of a sudden two files unless you created the files after the fork. So anyway, we have a pipe here, a single pipe, with two pointers, and we check switch. If the fork returns 0, then we know we're the child. So if case 0 child, then we say close the read side because the child's just going to write. And then the child goes and says write on the 1, which is the right side. And he writes hello father 13. He's got to say how much he's writing. And he closes the right side to put in. What does that do? What does that actually physically do?
What's a null?
Not a null.
End thing.
EOF, end of file. He puts an EOF into the file. Now the child does break. Break will get me out of the switch. And notice the switch just ends the program. So the child's finished basically here. Now default means that I'm the father because I got a number that was in the switch that was not 0. So if anything other than 0, I'm the father. And what do? I close the side that's writing because the father is not interested in writing. So essentially, he also puts in an EOF. So it's like the thing is fully closed. And now we do a read. I do a funny read here. I do a read from the read side of the pipe, but I just read one character at a time. I could have done it differently, but I read one character at a time. And I have to pass it there for a pointer to a character and a number 1, because that's how many I want to read. And now as long the read will return me 1 every time as it reads one letter. And then I print the character C. And this is not important this time. I just print the character and I keep printing in a loop until that's all as long as read is returning me 1 or any number not 0. When is it going to return me 0? When it reaches the end of file. Now what would have happened? So it'll keep printing until it hits the end of file, which is there because I put it there. And then we'll close it and we're done. So the father will print the message the child sent it. Now I have a question. What if I hadn't done the close FD1 or this close FD1, let's say? I've done either.
Infinite loop.
Well, what would happen with this? No, not infinite, not exactly an infinite loop.
The while will never end.
It will never end, but it won't. Will it run millions of times?
It will hang, I guess.
It'll hang. Why? What'll happen?
It'll never return 0.
The read will sit there saying, is there another character coming? Because he never hit the end of he didn't get another character. There's no characters there. And yet he's not at the end of the file because he didn't see an end of file. So he's just waiting for another character to be somehow fed to it.
It's a good exam question. Put it on the exam.
Yes, that's the kind of question I would ask. Okay.
Free point.
Now we're going to another topic. So now you basically have the basic idea of pipes, how a child can speak to the father, but we're gonna try to make it more complicated by this idea of dupe. First of all, we're gonna teach dupe, and then we're gonna teach dupe two. Dupe two is based on dupe. So I just want to explain dupe. Dupe is for duplicating a file descriptor. So for example, if I give you a file descriptor like 0, which is the keyboard, and I say dupe, I put 0 over here, and I say dupe, the integer that it returns will be the next free number in the table of file descriptors. Let's say 3 or 4. And that 3 or 4 will point to whatever 0 pointed to. What did 0 point to? Keyboard. So now I could actually theoretically read from 3 or 4 and or 3, let's say, and I'd be reading from the keyboard. It gives me a duplicate pointer to whatever file descriptor I gave you. Is that clear?
Could you just make a pointer to that place?
Well, it's not
Another
it's the operating system maintains a table of file descriptors for each process. I need to add a new entry to that table.
Why would you want another file descriptor that's empty? And not just make another?
Well, we'll see why.
Okay,
But for the moment, you're right. Why would I want 2 pointers to the keyboard? I might. I'm just saying what it can, I'm just saying it can do that. Notice that we're just reminding us that 0 is the keyboard, 1 and 2 are the standard out and standard error. So if you do new dupe stack dupe with 2 there, then now new FD is probably going to be 3. But it has all the attributes of 2, which means it also points to the standard error. So here's an example of using dupe, and then we're going to do 2. So I opened the file, and I opened it for append, read, whatever, and then I made a copy of it of the file descriptor that I got here. I made a copy of it with dupe, and now I do file D. I print out the number that I got here, and I print out the other number that I got. I print out, let's say, 3 and 4, probably. And then I close, here's an interesting thing, I close 3. So essentially what that does is it removes it from the table. But that doesn't mean I can't write to 4. So I can write to FD copy new data and it'll write. I just removed it from I didn't close the file. When does the file get closed logically? When will the file be fully closed?
at the end of the program, I
Well, at
guess.
the end of the program, but how else could I close it? What? No, and when does it close? That's just
But you close the copy.
when I close the copy. I have to close all pointers, all file descriptors. If there's 10 file descriptors in the same file, I gotta close all 10 before the file is closed. It won't, just closing 1 doesn't close it. Closing 1 just removes that entry from the table. Okay, another dupe example. This is gonna be a little bit more interesting. Because we're combining it with pipe and fork. So we do our pipe, we do our fork, we check on this time it's a little bit nicer, I check for an error. I check case -1, if it's an error, then break, I'm done. If it's case 0, then it's child, and I say child only writes, so write, so I close, child only writes, so close the read side. And then I say close 1. I mean, this example is not that interesting. I close 1. What does that mean?
You close right and read.
I closed, no, standard out. I closed standard out, but I didn't close right of the pipe.
Oh, yeah, sorry, you right.
The right of the pipe is still there. Child only right, I just closed the read of the pipe. I closed standard right. Now I do dupe of PD1. What's it gonna give me? It's gonna give me a duplicate number which refers to the right side, particularly the right side of the pipe. What number will it return here? I didn't catch the number. I didn't put it into a variable. It did, but it wrote a line in the table. It wrote a line in the file
Probably like 4 or something.
descriptor table that the operating system maintains for each process. What number would it write there? No, it always writes the lowest available.
Type me 2, so that's 3, 4.
Lowest available number.
5 is the.
No. Notice this line here?
1.
Yes, I closed 1, so 1 is now available. The lowest available number is 1. So now when I do printf, hello user, printf, what does printf do? He writes to the standard out, which is, from his perspective, the number 1. Where does it can actually get written to?
Pipe.
To the pipe. So now the printf, he's merrily going his way, and he just wants to write to 1. But he doesn't know that 1 has been switched on him. And now 1 is referring to the pipe. So he'll write to the pipe. So
What does it mean for a pipe to have written in it printf? What does that do?
no, printf is a function
Yeah.
that writes to 1. And what does he write? Hello user. So hello user is at the pipe.
Okay. Wow.
In fact, let's make an extrapolation from that. Well, we'll see. I didn't learn exec yet, but the point is, I can trick somebody. In other words, from the perspective of printf, he doesn't know anything about the pipe. He's just trying to write to the standard out. So anything that wants to write to the standard out, I can now force it to write to a pipe. And why is that useful? Well, I might want to be reading from that pipe. I might want to, and that's what we'll see. That's the lab. So now what does the father do? The father closes the right side because he only wants to read. He also closes 0. He also does dupe. So what's dupe going to return? Or what entry will it put in the table? What number will it return? What number will this return?
1.
No, it always returns the lowest number available. I close 0, so now 0 is available. So he's going to return 0. You understand? I close 0, so 0 is now free. So when dupe comes along and duplicates the read side of this, he will duplicate it with 0. So now both 0 and PD of 0 are pointing to the read side of the pipe. Understand that? I can have multiple lines in my file, in my table of file descriptors that point to the same thing. So now when I do read, here what I do is I do read from 0, which normally would be read from the keyboard. But now that 0 is actually the pipe. So I'm reading from the pipe 1 character at a time, just like I did before, and I'm putting the character on the screen.
What's put chalk?
Yeah, it's a function.
Really?
So I read again, and I do a while loop, and I read until I hit identify. So actually, the read could have been a scanf. Could have been anything that just reads from the screen, from the keyboard, because the keyboard is no longer the keyboard; it's now the pipe. And I'll read from the pipe. So that's already, we're seeing the trickiness that you can do. And now we'll learn dupe 2, and we'll basically see the same example with dupe 2. Dupe 2 is a little bit more convenient than dupe. Basically, it's a wrapper function for dupe, which means it uses dupe. But what it does is I give it 2 file descriptors, duplicates an open file descriptor, but it lets the user determine the number of the file descriptor. For example, the dupe2 function causes the file descriptor file2 to refer to the same as file descriptor. So in other words, this is the original and this is the copy. Just like we said by the copy function, right? You do copy file, new file. So, or it's always the new one is on the right. So file2 is a non-negative integer less than the current value of the maximum number of open files. Because you can't give it a number that's like astronomically large because there is no file descriptor that high. And you also can't give it a negative number. So what does it actually do? Wait, if file descriptor 2 already refers to an open file, what if I gave it 2 here, for example, or 1 or 0? So it's already referring to something, like the standard out or the standard in. So what does it do? It closes it and then reassigns it. If file2 refers to, if they're the same thing, if I write 1 and 1, well, then it just doesn't do anything. And it won't close it. So you understand that? So I can actually with dupe2 reproduce. Let's do the same example now with dupe2, and you'll see it's a little bit shorter. I just say like this. I make my pipe, make my fork, I check for an error, and I'm now the child. And I say, close the writing side. And now I say dupe2, this is the original one. The pipe, close the reading side. And now I say the right-hand side of the pipe should be duplicated by 1. Well, 1 is referring to the screen, but I'm going to close it and open it up again. I'm going to close it. It's no longer pointing to the screen. And now I'm going to make it point to the pipe. So now when I print hello user, it's going to directly go not to the screen, but to the pipe. By this dupe 2. By this dupe 2. And then I close, and then, oh, and then I did like this. I reset it. This is silly. I just wanted to show that I could do that. I reset 1 to the screen because 2, I still luckily had 2 as referring to the screen because
How did 2 become the screen? Could you do that?
because the error messages also go to the screen, don't they?
Yeah, but 2 is the error.
Yes, but error goes to the screen. So the Lamaisa, it is pointing to the screen. In reality, it's pointing to the screen. So I can say 1 now points to whatever 2 points to.
Error is
They
the
both point to the screen. What?
same with the error now then.
Nothing. I mean, just whether I know. Because if I do printf, it prints to 1. If I do p error, it prints to 2.
Yeah, so now you just made.
But where do they both go in the end? To the screen. Right? If I do p
How
error.
does that reset them? So now 1 is the STD error, not STD out. So no prints will go.
No, because it,
Copy your destination out the source. What? Source there, what destination?
I don't know what you mean by source and destination, but
I'm saying that the destination, the source is the error, the destination is the screen.
right.
So we're copying, we're giving 1 the destination of 2, not the source. It's still standard. 2 is still standard.
1 and 2 are identical, normally. In a normal circumstance, 1 and 2 are identical. Because the 1 maps to the screen and 2 maps to the screen. We call 1 standard error, or we call standard out, we call 2 standard error. But they're identical, they both point to the screen. So I reset it. This is just silliness. It's not, I mean, that's not necessary, because anyway, I get end. But then the parent process only reads, so I close the right side. And then I duplicate 0, so the standard in will no longer be the screen, but will be the pipe. Or no longer be the keyboard. Now I do read from 0 again. And I print same as the previous example, except I use loop 2 a little bit more short and maybe more understandable. Diverting the standard output to a file should do. I think this is pretty much the same thing. Let's see what this does. Again, I do pipe, fork, error, and the child only writes, so he closes the read side. And I say 1 points to the pipe. And now I just do print hello. So no, I did that before, I think. I print hello, I close the pipe. Now the father goes, does the same thing, 0, and he uses that's the only difference really. Instead of using read 0, I just use getS, the function getS, which is get string. Now getS doesn't know about pipes, doesn't know anything about pipes. He just tries to read from 0. But 0 is the pipe, so he'll read. Or he prints, I am a father, and then he prints the string that he read. Fine. Next. This is just a curiosity. People ask me, well, if I close everything, if I close the screen, how do I get it back? If I close the screen and the error and everything, how do I get it back? So you can actually, what am I doing here? Since we may lose access to the screen of the keyboard when using dupe 2, it is interesting to see how we can regain access to the screen. I don't know exactly what I did here, but I opened up a file here. I checked if it was negative, and then I said, I made 1 point to the file. So 1 is now pointing to the file. And now printf, hello file, does not go to the screen, it goes to the file. And I print standard error, string error, error number if there was an error. Make sure I finished, close 1. Okay, I closed 1. Now open file for write only will get 1. So if I closed 1, 1 was pointing to the file. I closed 1. So now 1 is available. So now if I open something, what is open going to give me back for FD? 1, that is available. So now 1 will be open of whatever I write here. And what file did I write? Dev tty. Dev TTY is the screen. It's device, dev stands for device, and TTY stands for teletype. It just means the screen. So I'm actually opening the screen as if it were a file for write only, because you can't read from the screen, you can only write to the screen. And I'm putting it to FD1. So now if I do printf, it's going to print, or hello world, it's going to print to the screen again. So even though I got rid of it, I can get it back by directly opening the device and resetting up my table. Because I can delete my whole table and recreate it. And that's why the standard error is the same thing. I could just do this again with 2. Then the standard error would point to the screen. I still didn't explain. I need to explain execv. Is that going to be here? Okay, let's talk about different topics. We'll get. Perhaps I'll have to explain execv. Maybe I'll explain it now. Here, stop share. Why is the screen? Why is that? Oh. So. Let me explain something. If I have a marker here.
Right about execv?
I don't think so.
What? That's like, you need that for the homework.
That's why I'm explaining it now. Exec.
You need to know for the test.
Yeah, sure. Execv, or first, actually, I think I do have a slide about exec. Maybe let me check.
Okay.
Let me check.
Okay, somebody's saying what?
It's not in here, but maybe it's in the next one. Maybe I
Yeah.
should move it. It's-
Walking down the main street. What about there's this slideshow? Let's jump that one.
We'll get there. I don't want to lose your attention by talking about something irrelevant.
No.
Yeah, here it is. Here's the exec.
Here we go.
So let's start this and we'll go back. We'll finish 8 later. Let's jump into this just while I get to really. I like to finish one topic before I run to the next, but in this case, I'll. What am I doing? I need to go here and share. Share. Slideshow. Okay. So here's execl. What is execl? Execl is a part of a family of functions of the exec family. There's execl, execv, execvp. There's a variety of ones. It replaces the. Here, I love this definition. It replaces the current process image with a new process image. Now, as it takes whatever process let's say my current process image is run this program. New process image will be run this other program. And I won't know anything on it. The other process is gone. I don't know. It's the same process. I didn't create a new process. I just sort of like imagine a process could be like a frame, a picture frame. I take out the canvas and put it in a different canvas, but it's in the same process. I just replace the image that is in that frame. The initial argument for these functions is the path name of a file which I want to run. In other words, a program I want to run. With me? Questions?
We say image, we have another program or
Yes.
arguments or, okay.
It replaces the image. In other words, a process image is the process as it exists in memory that's running. I can take a different process and put it in the place of that process. That process now, it's like, I don't know if you've ever heard of a movie called Invasion of the Body Snatchers.
I
But-
have, oh, no, that's a fun one.
Imagine like alien beings come and they take over
Oh,
the
too
body
scary, too scary.
of a human
Yeah,
being,
gross.
and the human being is gone.
Okay.
But he's an alien, but he looks and sounds like a human being.
It's not scientific.
It's not that science.
Oh, science fiction.
Next.
I really watch anything movie live.
So that's what's going on with the process. The process is being, interlooked upon. A new process is being put on top of that process. That original process is gone. That's what it says. That replaces the current process image, the new process image. The initial argument is the path. That's what it's here. The path for the program that I want to run. Excel expects a complete list of the commands and all the arguments you want it to run, followed by a null or zero. So in other words, if I want a program can have command line, you know about execv and argv and argc.
Yeah.
A program can be designed to take parameters from the command line. So I can run a program, but I may want to give it parameters. So that's this. Notice there's 3 dots here. I can have an unlimited number of strings here, which are the flags or parameters that I want to give the program that I want to run. So the name of the program is here, followed by a bunch of flags. Now and then at the end, I have to have a null to indicate the end of the list. Otherwise, there's no more elements there. So let's see a very simple example. In this example, we're going to run the program called ls, which you're all familiar with. The program control passes to the program ls, and none of the following statements, if there are any, in the original program will be executed. Of course, if exec, no, let's think about this. If exec L occurs inside of a fork, then of course it is possible to have the parent who's not running the fork, who's not running the exec, continue execution of the original program. But here, for example, like this, files in the directory are exec L, and then I have to type bin ls, and the weird thing is I have to write ls again. I don't know why they wrote it that way. It's Kilu, another argument. I have to write the path, including in the name of the program, and then again write the name of the program, and then the parameters that I want to give it. In this case, I just gave it 1 parameter minus L and a 0. Now this line will not execute because if this will find it, it'll run this, and the process will now be ls. ls has no knowledge of this program anymore. So how will it come back? It won't come back. It's replaced. But there is a circumstance where this will run if exec fails. If exec does not find, if there is no ls in bin, then it won't run it, and it will run the next one. When can that be useful? Imagine that your person types in ls and you want to tell them, and if it runs, it runs. And if it doesn't run, you want to write command not found. So you just simply write command not found after the exec, and it will run if it didn't find it. And it won't run if it didn't. You don't even need an if. Now, I'm going to show you the same thing. You actually, in your program, you're going to have to use execv.
Yes, sir.
Not execl. And execv is just with a vector. V stands for vector. And here I made a vector. A vector is just a 2-dimensional array. And I gave it string, ls minus l, a.out. That's the name of the file. I gave it 2 parameters this time. And 0. And now I do a fork also. Look at this. I do a little. That's why I taught the wait. See, I skipped over this.
This is how you do the homework.
Yeah, this is how you do the homework. I do a fork. Now I'm the child. If it's equal to 0, I do exec v, and I give it this string. I still give it the path, but now I give it the vector, which is the parameter list. This allows me to put in as many things as whatever I want here, and this is hard coded as an array. If I had hard code this as ls, then I could never do anything different. Now this is a string and this is a name. I can always change this string in. I know exactly how many parameters I have. In other words, in the other version, if I had 6 parameters or 7 parameters, it'd be different. Here, it doesn't matter. I always have 2 parameters. So I can write this, and it doesn't matter how many parameters the guy gives me, I'll just put them into an array, and then I can give it to him. Now, if this exec didn't work, I'll write command not found. Now the father, meanwhile, fork does not equal 0 by him. So this is the father. Notice that actually the son, if the command is not found, we have a certain weird thing that's happened here. If the command is not found, then after this if, the son will actually execute these 2 lines. Kind of a mistake. I should have written an else.
You're right.
Because if he doesn't find it and he says command not found,
It continues.
then he'll just continue and he'll do these two lines. Now, the wait on status won't be a problem. That won't be a problem. He'll just say, I don't have any children and keep going. But this will, they'll say finish twice. Now, the father is doing wait command. What the wait command does is it says, wait for any child that I may have. I don't know how many children I have. I don't care. But whichever child finishes first, wait for him and don't continue. So I want to finish executing the command will only be printed after this gets printed. I won't have a race condition. I won't have the possibility that this prints before this, which is relevant to your homework. Why? Because you want the prompt, that the little caret, the little arrow, the greater than sign, to be printed after the command runs. You don't want to be printed in the midst of the command. So you'll run the command, and then when it finishes, you'll print a new prompt. That's the basic thing. Now, how does this have to do with the do? We didn't put everything together, but here.
How does wait alter status?
That I'll explain later. I'll have a whole slide about wait. I'll talk about that. Now, what about diverting output of execv to a pipe? Now, imagine that the person wrote on the command line ls pipe wc. So you actually have to have a child running ls and a child running wc. They're two children. Because, right, if one child runs ls and then he finishes and he's dead. Now another child will run wc. Each program needs its own child process. And I want something more than that. I wrote ls pipe wc. So what is actually I want? I want that the standard input of wc will be whatever ls put into the pipe. So I want wc to read from the pipe and ls to write to the pipe. So how do I get execv to write to the pipe? Let's talk about that. We have ls, we're going to write to the pipe. That's the first step. So I simply do what I did always. Fork, am I the child? Yes. But now I do. And I say, write, when you run the execv just says, I want to write to the standard output. That's what ls does. ls writes to the standard out. But I'm going to pull the wool over your eyes. I'm going to, before I run you, I'm going to change that one is the pipe. So when I do the execv, remember, he inherits from the, he's still in the same process. It's not a new process, it's the same process. And so therefore this change affects him. The file table is the same file table. There's only one file table for process. So when I do execv, the file table has already been corrupted in this way. I've already changed that one points to the pipe. So when he does bin ls, he runs ls, it's going to write to the pipe. And then the father will wait. By the way, he'll finish, he'll execute. So automatically, an end of file will be put into the pipe. I don't need to do that. Because when execute finishes, the program ends. And that's the biggest EOF that there is, right? The program ends automatically, and EOF gets in. So now I can do read from the pipe, whatever is in the buffer, whatever is it, and put it in the buffer. So now here, what you'd actually want to do, and if I had a WC here, is I would want to make another child and make him read from the pipe. In other words, I would do a dupe again with 0 being the pipe. And now when I ran WC, if WC has no arguments on its right side, it automatically goes to look at the 0, at the standard in, and it'll do that. And it'll read the pipe.
What is fluff?
Well, that's just the name I gave to my buffer. I didn't define it. I forgot. You're right. There should have been another line over here that says buff.
It's not something that's.
No. It's a character array. I just called it buff. All right, now let's go back to lecture 8. That's basically the whole idea. The only complication is how do you deal with multiple pipes? How do you deal? You have to have like you could have 7 pipes. you can't just hard code two. You'd have to figure out a way of doing a loop. All right, let's go back to 8 because I skipped 8. Just to fill in the gaps. Here's 8. Okay, so we were here. Wait, you asked about wait. So wait waits for process termination to occur. The wait function suspends the execution of the current process until the child has exited. In other words, I don't do it. The parent who's doing the wait is suspended
All the children or just the child?
until a child, it's any child, has exited. Or until the termination signals them. Obviously, if you do like control C, it'll fine. But he's held. If a child has already exited by the time of the call, that means the child executed before the father even got to the line of his code that says wait. Well, then the child is going to be called a zombie. But what's going to happen when he gets to the wait? Well, the wait will return immediately because there's already a child like online. There's a child waiting online to be waited for. So the function returns immediately. Any system resources used by the child are free. Fine, if he was using so if the operating system is keeping track of some things about him, he's now completely released. The child is not really dead until his parent waits. This is so in order to allow the parent process to find out the child's exit status after he already terminated. Okay, so that's what wait does. Here's an example where status is an integer. And I do wait with I give it a pointer to the integer, so the status is empty. But after I call the wait, then I could theoretically check the status and see what number is there. Like it would be I think it would be the return value if there's like I never remember that exactly, but I think if there's a return 7 at the end of the program, usually you write return 0 at the end of your program, you could write return 17. I think the 17 will be the status.
How does it get status?
Not sure, but the operating system gets.
You guys called status.
No, I don't have to call this thing status, I could call this thing cuckoo. And then this would be called ampersand cuckoo.
Why does the child?
Status.
What?
Why does the child return anything to status? Why does it return it to?
It returns it to the operating system, and the operating system puts it into the variable that I specify here. I can call it whatever I want. That's what wait does. Actually, there's another thing. Wait also returns a number. I don't remember actually at the moment, right? I forgot now what the difference between the number of the status and the number of returns. We could check that out. See what's this? Oh, PIDT. No, PID type. That's the number there. We see exactly what it is. It's a PID type. So that means this is the status, the return value, but this is the PID because it could be that I had 3 children and I don't know which one died first. And I get the PID there. I think I actually have an example of that. Now I remember. Yeah, here's an example. So you see, first I did child fork and I kept the value of the child's ID. If it's equal to 0, I did these parentheses because of order of operations here. If the child 1 is running, so I'm the child. And now I'm the father, and in the father, I make another child. Child 2 is running. Now else, I'm really the father, right? So child 1 is running, child 2 is running. If it's 0, right, then I'm a child. If it's neither 0, then I'm a father. Now I do PID wait status. Now look what I can do. The PID that I got is the PID of the child. So if the PID equals child 1, well, what's child 1? If I'm the father, then child 1 is not 0, but child 1 is the PID of the child. So child 1's PID, if the PID that I got over here is child 1, then child 1 terminated first. Else, if it's not child 1, it must be child 2, well, child 2 finished first. I'm just showing that I can use, the fork gives me the child ID, and then I can use that to check which child finished. I can also, there's a function called wait PID, where I can say wait for child whose PID is this value. Now here I do the same program, but I do it twice. I do twice wait. I do twice wait, so that now the PID will be the value of the second child's finish.
Most people terminate before, father gets the ID rate, the first, is it this right?
They both terminate before, there'll still be some order. There'll still be some order, and the operating system will, I presume, give me the order the correct order.
It's not.
It may be,
overridden. Standards don't work, like the wait signal doesn't get overridden by a later child.
no, each wait will return one zombie. No, we'll take care, we'll reap one zombie. All right, that's it for the wait.
Wait,
Now we go back to 9.
and like I do, wait. Okay, my phone, turn off the AC.
We finish 9.
I don't know, it's-
So here we are at 9. Sorry for jumping around, but I think it's recorded. Slideshow. Current slide. So there happens to be another function called system, which is a wrapper function, which does all the work for me. In other words, it creates a child and runs execv. And I can just therefore write system VM stat 1 or some, and I can just give it like ls minus L. And it'll find where it is, it'll look at all the usual places.
Can we use this in the homework?
No. And then you just run it and then it'll print, and hello will get printed to the screen. Because it's a child, it does all the work, the child and the father's all there.
Makes it easier.
No, you can't do that. I want you to learn how it's done underlying that. This is a wrapper function, it does a lot of work to it.
Yes, sir.
There's also a function called p open. Essentially, p open combines several other system calls. It creates a pipe. It forks a child process to run a command. You also can't use this, but I'm just showing you what it exists. The output of that command is then returned via the pipe and pointed to by the pointer returned by the call to p open. You have to see an example. P close waits for p open to finish execute. Okay, so here you see that p open, look at it returns. That already tells you that it's not a basic function. It returns a stream, right? A file pointer. It returns a stream. And it takes a command and a type, okay. And p close also takes a stream.
It takes that screen.
The command, in other words, when I say command over here, this word command, the command argument is a pointer to a null terminated string containing the command line. So in other words, the command could be like ls minus L. The type argument specifies only reading or writing, not both. In other words, when you open up P, you have to decide, am I the writer to the pipe or the reader from the pipe? So you have to specify the type. Is it a reading or writing situation? You have to see an example. The return value from the P open is a normal standard IO stream. In spec say that it must be closed with P close instead of F close. Remember a stream, we learned about the F functions, and it would be you close it with F close, but here you close it with P close. Writing to such a stream writes the standard input of the command. And the command standard output is the same as other process called P close function waits the associated process to terminate and returns the exit status of the command. Okay, P open function returns null if the fork or pipe calls fail. If it for some reason can't do a fork or can't do a pipe, then P open, this would be by an interesting homework assignment actually, to implement P open. That would be interesting.
That's not like included in the system.
It's kind of included in the homework that you have to do, but to implement it, no, to implement it exactly as it's written. Right. All right, let's see an example because it's a little bit confusing with just words. Here's an example. So what do? First of all, I create a stream. I call it PFP. Pipe file pointer. A buffer, and now I do P open, and I do ls minus L, and then I give it a file name, another file name, and close the string. And then I write R, and R stands for read, which means I want to read. Now it's going to give me back this PFP, which is the pointer. And I check if it's null. If it's null, then it's some kind of error. What did I write here? The command failed, exit 1. Okay, let's assume it didn't fail. And now I do like this. F get S, which means file get string, which means it's this. Remember we look. It's part of the F commands that read from streams. So get a string from here, and put it into buffer, which is buffer size. So I'm gonna basically run the command ls minus L, and it's gonna print out a whole mess of strings. Whatever strings it's gonna print out, they're gonna go into this stream. And now I'm gonna read from this stream with fgetS. And I don't have to have a child here. No. I just read from it. So I basically did popen, I ran the command. It's kind of like the system idea. In other words, it allows me to run a foreign command without losing my program. Normally, if I would do execv, I would lose my program, I'd take a child. Here, it made a child and made a pipe, and now I can read from the pipe, and then I can print out the buffer, and then close the stream. So the output of the file would be this. File 1, because I wrote file C++, which starts off at 1. File 1 in the current directory is, and then string. Whatever string is string, which is the buffer, which is this buffer. So file 1 in the current directory is, and then that's the output of ls minus L on popen. And then again, file 2 in the current string is ls minus L of temp 0. So that's the output. But let's see one more example where we see the other way of doing it with right. This is a little bit weirder. Here I'm saying open a file stream with sed. I'm running this is the command I'm getting. I'm giving it sed e switch little a to big A globally. So all the little a's, and then I do write, which means I want to write to this pipe now. In other words, I'm going to write, so that means this command is going to be reading from the pipe, but I want this thing that it gives me back to be writable. That's what the W means here. It means this is writable. Just like the other one was R, because I wanted to read from it, so it was readable. Here, this PFP is writable. So now look what I can do. Print F to the PFP. I'm going to write to it, apples are tasty. So now I wrote to the stream, and the stream has on the other end of the pipe, this guy's reading from it. Well, this guy, when he reads from it, he doesn't just print it, he switches it to apples are tasty. With capital A's. See that? So that's popen. That's that's not part of the homework. I just want you to know that how to use it. This you don't have to. The only thing I want you to know here actually is this one line here.
That's French.
It is French actually. This is an This is a teacher taught the course said you have to teach this. So I said okay, but it's actually interesting. I could explain it if you want me to, but this is the main thing I want you to know, which is just that you can run get end, and then give it a path. This is you're gonna have to do this in your homework.
You got homework 6. We did it.
And then now you got the path, like all of the streets. Okay. But the other stuff there you don't have. That's it. So we did 8 and 9. That's enough. That's enough for today. But you can have lab.
Right. We're gonna
What's not
homework 6.
Or
or forward 5, depending on
If we did 5, it's more about 6.
I think what is 6?
6 is the last one, and the course ends in a month, so.